want to talk about a little bit is obviously, some current technologies and what we're going to be doing in the future. But because I've been around for so long, thank you for reminding everybody, that I'd like to remind us, like, where did all this start? We all say, we've got engines now that are super clean, very efficient, honest million miles. And, where did all this start? So, as a joke, in 1998 at Mac, we ran this ad in all the magazines, and it kind of, we knew even back then that, diesel fuel should be sipped. I'll have you know, we did get letters from the SPCA wanting to know why we were giving diesel fuel to a bulldog. I kid you not, okay? That's the truth. Information and control evolution is very, very important. In 1976, that's when you started, we had some rudimentary engine controls. Basically, it was an RPM limiter that would engage itself mechanically when the transmission went into top gear. And that was about it. And there was probably, if you were mechanically, as dumb as a box of rocks, you could defeat this device in 13, 14 seconds. So, but it was a start. We had our 1987. We had our first generation of electronic engine controls, and that was from our friends at Detroit Diesel. They did a great job, and they introduced RPM speed controls, fuel injection. It was quite a leap forward for the industry. 1991, that was the second generation of electronics, and that's when we started to get smart. We started to add all the things that engine control systems, engine management systems, shutdown systems, protection systems, you name it. We started to add it, and it added value. Of course, it added cost, but we got our money back. You customers got their money back for the investment. And also 1991, the first commercial AMT came out, and that was the Eaton Auto Shift. And again, that was certainly a game changer. It was a very interesting technology, and in fact, it's a technology that it's growing even today. 2002, Christine's company. It was the first generation of what I'll call newer turbo machinery devices, variable geometry turbochargers, things like that, that really made a difference to the diesel engine. In 2007, our friends over at Volvo, they're across the campus from me. They don't let me over there, so I just have to, I wave at them out of the window. They introduced the first vertically integrated engine and transmission combination. And again, that was, a trendsetter for the industry. The beauty of that was it allowed the engine and the transmission in the vehicle to share 100% of the information 100% of the time. So there was some interesting management things that could be done between the three ECUs to improve performance and fuel economy. 2009, obviously a broadening of the engine management control systems. Smart engine cooling fans came into practice where the fan would be managed electronically. 2010, the third generation of electronic vehicle controls, and we had smart, or as I like to say, smarter powertrain management systems. You had electronically controlled shift points for manual transmissions that would actually vary depending on the load, so it wouldn't be a fixed RPM clip all the time. And of course, power management. This is probably one of the most interesting things that we're working on right now is, torque-based power management or load-based power management, meaning that what we do is we only supply the amount of power that is required to move the load at that particular time. And for example, when the truck is fully loaded, say at 80,000 pounds, we give the driver 100% of throttle authority. So he gives it 100%, the engine demands 100%. When he's coming back and it's now down to 35,000-pound GCW. If the driver demands 100% power, guess what? We give them 100% power. So we figured, well, what can we do to kind of slow this down? That's a lot of wasted energy. So it's mass-based variable torque, or as we call it, load sense. And that is, certainly a big step in the right direction on managing fuel going forward. Applying beneficial information, and this is one thing that, we're probably all been talking about today, is you've got a lot of this information. What do you do? How can you glean some benefit to all this information? And today we're all accused of TMI, too much information. So what do? So as OEMs, we like to be able to provide you as much information as you need, but then we also can filter it to your particular application and apply that knowledge to your particular application. So what we like to do is certainly understand the requirement. And as you can see here, whether it's a refuse collection vehicle, flatbed hauler, package service, or a tanker, these are all entirely different duty cycles. So the expectation from the customer is entirely different in each one of those situations. So what we want to do is to be able to tailor the entire vehicle to that customer's requirement and duty cycle. And what we're trying to do is maximize the operating efficiency of the vehicle, because as you may have noticed, they are not getting cheaper over time. So what we like to do is do our best to make them as efficient as humanly possible. And again, how can this be done? We can gather all the information of the vehicle performance from its first day to its last day. And we can filter that information, and we can tell you the amount of power that that vehicle demanded over a span of time, its entire life, over a day, how much fuel it used under given circumstances, how it performed at altitude versus sea level. So we can take all that, and we can take that information, and we can hone it down, and we can polish it, and we can serve that up to the customers is the best that we can do. Reaping the advantages, again, I talked a little bit about it earlier. Load-based variable power programming. Again, we've got 3 levels. We've got the light, medium, and heavy. I'd like to come up with some more interesting marketing terms for that, but I can't, so it's going to be light, medium, and heavy. And what we can see here is in a typical 80,000-pound or less than 80,000-pound highway operation, that'll pick you up about 1% in fuel economy. And as I said earlier, the silver bullet, the trigger was pulled on that silver bullet about 12 years ago. There is no more thing where we're going to do one thing and get you 3% or 4%. We're going to have to take a bundle of things and get you that 3 or 4%. That's how efficient the trucks and the engines are today. They're very, very efficient. Smooth cruise speed controls. Basically, that's, industry could refer to that as smart cruise. And what we basically do is we desensitize the cruise control system. Again, it's another one of these features that you get into a rolling hill. You go down the hill, there's 0 throttle input. You go up the hill, it gives it 100% throttle right away. So what this does is somewhat desensitizes it, and again, it will actually roll on the throttle. And typical rolling hill interstate, there's about another % there. I just kind of explained all that. Smart engine cooling fans. We've noticed over the last few years, certainly when we got into EGR engines starting in 2002, we ramped it up in 2004. And then into 2007, heat management was certainly the name of the game, and we were requiring more and more of a fan and a cooling circuit. And when you require more of the fan, that requires more horsepower. More horsepower requires more fuel. So we would rather channel that fuel to moving the vehicle than cooling off the engine. So we introduced some very, very intelligent fans from a variety of vendors that have done a great, great job in that area. And there's about a 1% gain. Load sense, mass-based variable torque, there's about a 1% gain there. So there's a lot of technology that's involved with what you see here, but it's a 4% gain. And that's really, you know, what we talk about. That silver bullet, like I said, the trigger was pulled on that a long time ago. Oh, the last thing here, electronic programmable shifting. This is a device, it's an electronic control system that again works on the amount of energy that is required to make the shift and move the load. So it'll actually adjust the RPM shift point on a conventional manual transmission so it acts a little bit more like an AMT, so it won't allow a whole lot of, you know, extraneous high RPMs for no good reason. Today's technologies, ultra low speed engine operating range. We now have engines, we call it the Super Econodyne. You can cruise down the road now at 1100 RPM. I mean, if you'd have told me 2 or 3 years ago, I can give you a reliable engine that'll go down the road at 1100 RPM, I'd have sold you a bridge in Brooklyn. I mean, I didn't believe it. But we get 1.5% gain there. Clutched air compressors. Now there's a very smart idea. You know, we drive a clutch or an air compressor all the time, whether you need it or you don't. So imagine putting a clutch in there and then using the air compressor when you're going down a hill. You know, all these little smart ideas. You know, you pick up about 0.75% with that. Notice we're getting kind of small here. Puff top speed limiters, that's something that we're going to introduce this year, and it'll be going into part of our greenhouse gas program, is we can allow a customer to have, say, a fixed road speed limit of, say, 65 miles per hour, and for a certain amount of miles or a certain amount of time each day, we can allow that 65 mile an hour speed limit to be increased by the customer desired limit, 1, 2, 3, 4, 5 miles per hour. And what that does is that gives the driver the ability to pull out and pass somebody. I was born and raised in Toronto, and I was up for a visit not too long ago, and one thing I noticed in Canada, they've got speed limiters now on all the trucks. They're all 100 kilometers an hour, which is 62 miles per hour. So when you drive between Toronto and Montreal in a 401, you see a convoy of trucks like you've never seen in your life because nobody can get out of the way of the other guy. So you'll be going down the 401, it'll be like no traffic going eastbound. And then about 5 minutes later, here comes this just massive trucks. And you go, well, what happened? And one of the fellows I was with said that's what fixed speed limiters will do for you. So we've got this puff top speed limiter. Hopefully it's intelligent enough that it'll let it alleviate some of that situation. We introduced a new engine. Actually, it's a whole new engine for us, but it's an old name. It's an Econodyne. And basically, it's power only when needed. Okay? This will reward the driver if he operates the engine properly. If he allows the engine to come down to 1300 RPM and holds it there for 4 seconds, we'll give him an extra 200 pound-foot of torque. And as we've all proved throughout time, the greater amount of time that we spend in top gear is directly proportionate to how good your fuel economy will be. So that's what we want to do. Keep it in the top gear. I just said that. The lower torque curve returns at 0 throttle input. So again, as the driver doesn't need that power anymore, takes his foot off the throttle, it goes back to the old fuel file. So again, saving more fuel. One thing that was really important to me is there's no kick in the pants feeling here. It just makes the transition very, very smoothly because you know and I know if there's that kind of jolt or kick in the pants feeling, the driver would be slowing down and speeding up all day, so it kind of defeats the purpose of improving fuel economy. So that was something that was very good. Also, new to us at Mack is a 12-speed automated manual transmission, the M drive. And keeping with my belief at Mack, keep it simple, stupid. So we've only got 2 options with this. You can get the fleet version or you can get the premium version. And that's about it. It's basic as that. And the reason for that is there's a lot of electronics, there's a lot of controls in it, and we either wanted to maximize control or minimize control. Maximize for the fleet, reduce the driver inputs, maximize for the owner-operators, the smaller fleets that allow their drivers a little more input into what they're doing. Advancing forward, what are we looking at? Besides the obvious natural gas and what have you, waste heat recovery. Waste heat is the amount of heat that is created by combustion that is not harnessed into motive power. So if we're not moving that truck down a road and there's a lot of heat going out of the exhaust or there's a lot of heat going through the cooling circuit, that's wasted energy. So what we want to do is try and capture some of that wasted energy and reuse it. Two-stroke engines. I was talking at the TMC earlier this year, and Chuck Blake from Detroit Diesel actually got tears in his eyes when he seen this one. This is something we could be looking at in the future again. I'm not going to say it's going to be an 8V92, but it will be or could be a two-stroke diesel engine. So, what's old is new again. GPS-based vehicle control systems. We believe that we can now manage the vehicle through telematics. So we can introduce geofencing, where the truck will only operate within a specified geographical area. Real-time vehicle speed controls for a local area. So if you go from Ohio into Pennsylvania and the road speed changes, then we would change the road speed limiter telematically. Horsepower output for a specified area. If you're operating a truck in the Midwest, 80,000 pounds in the Midwest, your power demand is really not that great at any time during the duty cycle. You take that same 80,000 pounds, you put it in the eastern seaboard, rolling interstate, it's going to require some more power. You take that 80,000 pounds and you put it out west in the mountains, it's going to require a lot of power. So what we want to be able to do is control the horsepower based on the area that the vehicle is operating in. Some of the fleets that are national fleets, this will be something that we can look at going forward. And thank you, and good morning.